This video is just going to give a short attempt at a definition of what data science is and what a data scientist is. As you go through this, I'm going to probably say this a few times that this is actually something that's very hard to specifically nail down, mainly because a data scientist can be such a wide spectrum of positions based on the company or the position that you're working. So I'm going to try to put a circle around it as best I can, but just be aware that you go into one company, it can be one thing, and you go into another company, it can be a completely different role. As often is the case with these things, I'm going to start with some definitions. And I do this because I want you to understand that this isn't my definition necessarily of a data science, or what data science is. It's more of a definition that you're going to see repeated, I hate to use the term, but buzzwords with all of the different ways that people define data science. Now, the first one, of course, got to start with Wikipedia. Data science is an interdisciplinary, that's my emphasis because I think that's super important, field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from many structural and unstructured data. Thinkful.com. I'm just going to hit the big words here. Obtaining insights and information, really anything of value out of data. Investopedia. Meaningful information from large amounts of complex data, data-driven. These are the kind of words that you're going to see again and again. Statistics, computation, decision-making, all big words. Oracle.com, multiple fields. There's that interdisciplinary again. Statistics, scientific method, data analysis. Again, value from data. And then this last one from Tech Terms here. Multiple methods of analyzing data, extracting useful information, gaining insights and knowledge. Structured and unstructured is also important in that case. So again, these are just different definitions I pulled down from different places around the web, and you can see there's a lot of overlap here. Here's a visual just to kind of give you an idea of where the discipline of data science really comes from. And this is where that interdisciplinary item I spoke of earlier comes from. You can see that there is a bunch of different areas involved in what creates data science. Just going to work my way around the clock here, starting at 11 o'clock, I guess, with data engineering. I mean, the data engineering aspect is taking what is oftentimes a large and unstructured and unwieldy source data set or multiple source data sets and boiling it down into something that is more structured, more consumable, more operationalizable. Data engineering is a major aspect in the data science process. Continuing around the clock, scientific method, you need to be able to utilize the scientific method in organizing yourself as you build out these data science modules. Obviously, math is important. You need to be able to understand at some level the underlying math behind many of these models. You do need to understand statistics to a level to know what a linear regression or a logistic regression model is doing to the data, as well as understanding the outputs that come out to make sure that your model is meaningful and replicatable. Advanced computing, being able to utilize programs like Python or R or SAS to attempt to build out these models or use these modeling tools. Visualization, that's one that I really think separates your data analyst from your data scientist. Being able to take these beautiful insights that you have discovered from your incredibly large data and boil them down into something that can be consumed by a larger community is where the rubber really hits the road for a data scientist. It's where you prove that you bring value to the company. If you come up with this really interesting, really valuable insight, but you can't explain it to someone outside of your data science team, then you are not doing your job. As a data scientist, you need to be able to make the information you've gathered consumable by someone that is not as scientific as yourself. Of course, the hacker mindset. I think a lot of people, when they see data scientist type work, this is something that really clicks with them. Wanting to be able to get into these large data sets and find this nugget of useful information is really, I would say, one of the sexier parts of data science, being able to dig and find something of value. And then the domain expertise is also critical, especially for a data scientist that wants to be successful in a large company. You need to understand the larger organization to know what is going to bring the most value to them that you can pull out of the data that you have available. Just another diagram showing, again, that multidisciplinary function. Venn diagrams, of course, are always fun. You need to have that combination of domain expertise, statistics, data mining, and programming skills to really have that sweet spot for data science. And then, of course, in the left here, it kind of stands apart, but the big data part is also important, being able to pull in that large data set and boiling it down into something useful. This is it's also a Venn diagram, but it's capable of putting together 4 different categories and all the overlays that are involved. Some of these are kind of funny, but you've got your communication skills, your statistics skills, programming skills, and business skills are the 4 circles here. And if you don't have at least some combination of these 4, according to this diagram, at least, you can't be the perfect data scientist. It's a bit of a misnomer. There's always the term about the data scientist unicorn, because they don't truly exist, the perfect data scientist, but it doesn't mean that there is no such thing as a successful data scientist. Everybody that works as a data scientist has to have some level of all 4 of these skills, but some are stronger in some areas or others, and some companies value some of these areas more than others. So it's just, again, it depends, back to what I was saying at the beginning. Just a few other things here. Like many fields, the role of the data scientist is difficult to nail down, as you can see. These positions vary greatly between industries and company sizes, again, as I already said. And this is also an evolving field. So even if you can nail down the definition today and come back in 2 years, it's going to probably be quite a bit different. It's a rapidly changing industry as some of these large companies, Google, Facebook, they are attempting to figure out ways to simplify a lot of these complicated processes that require a very expensive resource to be able to boil down this data. They want to make it something that is easier to do and, of course, then less expensive to create. And then I just like this general definition because I like to boil things down to simplicity sometimes. Data scientists are responsible for maximizing the value of a company's data assets. When you are asked to justify your position at the company, these are the kind of things that you would want to show. Like, you need to say, here is how I am bringing value to this company. A few other visuals here kind of showing the different roles that are either work directly with or adjacent to data scientists in these processes. You can see data scientists about 2/3 of the way down here, but you've also got the larger team. Now, this kind of shows the process from an opportunity discovery, like here's an opportunity that we can try to find some value through creating a pipeline to get that data organized, through creating models to boil that down into something valuable, and then putting that useful information out in a consumable fashion by the community. And then operationalization is all about continuing to keep that value fresh. Your data sets are typically not static. They continue to grow. They continue to be updated with new information. So that operationalization is important to make sure that that value that you're bringing continues to be valuable in the future. And then evaluation, decision, and action is also something that is with your SMEs and in your business side, but also very important to make sure that action is being taken on the information that you've gathered, and you continue to bring value with that information to those people. So you can see that there are different people that fit in different parts of this. Data scientists, sometimes I think that this line, even though it shows blue to an end here, I think there should be a dotted blue line here over to opportunity discovery, because I think it's important for a data scientist to have involvement in that. They may not have to own it, but they need to be involved. And then I believe it's also important for a data scientist to have a dotted blue line through this operationalization to make sure that the value that they are bringing continues to be valuable. But there is a team around these things that are typically more directly responsible for them. This diagram has a lot of stuff on it, but the thing that I really like about this one is it is showing that the data science team has to have touch points across the entire process. You cannot live in a vacuum in a data science team. You need to be working directly with the data engineering team who is organizing your data and helping it be consumable by your models. You need to make sure that the UI web applications team is getting what they need and what they're displaying to the larger community is easily consumable for them. And you need to be closely aligned with your subject matter experts to make sure that the larger business is going to gain value from what you're creating and that you are creating what will bring value. Just one more visual here that I want to do before I wrap up. Again, these are those skill sets. This is kind of in some ways a flattening of that Venn diagram from earlier, but your data scientist has a long line in the spectrum. You know, they need to have those software skills, that hacker mindset. They need to have database skills and understand what the data engineering team is doing. They need to know some level of basic statistics. They need to be able to create a simple view of typically or often complex topics. They need to understand some of the advanced scientific method to make sure that they're coming at these things in an organized manner, and they definitely need to have domain expertise in machine learning. And so this spectrum, the reason I like this one is because it also includes this structured data versus unstructured data, and that this end of the spectrum is more your enablers, and this end is your enhancers. So this is from the aspect of the roles. Your data engineer, your data analyst are typically on the enabler side. They're getting things prepared in such a way that they can be utilized, and then your data scientist, somewhat your business intelligence person, and your research scientists are enhancing that data to make it more valuable. That's all I really wanted to show in this video. Here's references if you want to go back to the sources for some of the visuals and the information that I brought into this presentation. So now go ahead and make sure you've completed all the work in the module, and then you'll be ready for next week.